Hi everyone, welcome to today's live video where we're going to talk about Docker and Kubernetes. Uh, we're going to start by saying what Docker is and what Kubernetes is. And yeah, welcome. Uh, yeah, you can ask questions, you can comment, you can do anything that facilitates your learning. Uh, why do we need Docker? Why do we need Kubernetes? One, today we are talking about software deployment. As a software developer, you first do your you develop your application. For example, I can show you an application I've developed here. This is a simple Swagger application. Just to demonstrate what Swagger is. It has several endpoints. Let me make it clear so you can see. We have this endpoint that will give us a result. We have another endpoint here and quite a number of other endpoints, but that's not what we're interested in. We're interested in how we package this application. One thing, we want to deploy it on the cloud. And when you're deploying it on the cloud, the cloud hosting, let me show you some cloud hosting here. You can have cloud hosting from AWS or from Azure. You can also have cloud hosting from Google GCP. This is GCP, Google Cloud. So you can deploy your application on this. What the cloud hosting gives you, for example, we have here, we have, for example, on Amazon EC2, EC2 means elastic cloud, whatever something, elastic cloud something. So we have, they offer one kind of virtual machine that has, let's say, an instance. They call them instances. It has A1.medium. It has 1 CPU and 2 GB of memory. It has some EBS memory. That's kind of a diverse topic. We have another kind of virtual machines, which we think of them as which is A1 large, and we have A1X large, and we have so many different of them on EC2. When we come to Azure, let me see where they are. I think they're here. Price, yes. We have this kind of B, whatever, 1 CPU, 1 gigabyte of RAM. And we have this kind of this virtual machine that has 2 CPUs and 4 gigabytes of RAM. We have this one that has 2 CPUs and 8 gigabytes of RAM, and we have this one that has 16 gigabytes of RAM and two CPUs. So when we come to, after we have developed our application, it can be of any language. You can, if you are a Python programmer, you can write your Python code, then put it in a Docker and deploy it on a Kubernetes cluster. If you are Java, you can do exactly the same. If you are Elixir or any language, you can deploy application as a Docker container. What is Docker? Docker, we have seen the before previously we used to deploy our application directly on virtual machines. You could buy this virtual machine which has one CPU or two this. So uh, let's say I have my application. Let me show you a practical part of it. Here I have my Spring. This is a Spring application, a very simple Spring application, and I want to let me run it. Here I'm using Docker, and let me run it and see what it does. Uh, this application actually got it from Docker Hub. I will explain what Docker Hub is, and let me show you where Docker Hub. Docker Hub. My internet is a bit slow, but before, let's see. Actually, it's my machine that has slowed down. Let me close some stuff that are not needed right now. Yeah, actually, this is Docker Hub. On Docker Hub, there are what we call Docker images. On the first page, you can see the most popular being Oracle Java SC, Java 8 SC, we have MySQL Server Enterprise, we have Couchbase, we have all these images. When we create our application, let me not exit. When we create our own application here, then we create a Docker file here. We create after we we build this, we package this application as a Docker file. It should be an image, then we can push it to the Docker Hub. Here, we see on Docker Hub, here on Docker Hub, we have these are images. Someone created the applications. This one is for Java JVM, Java runtime environment. We have this for database. We have this for Couchbase. Couchbase is a database, also an SQL database. We Alpine. We have Nginx. We are going to use this. I'm going to show you. If you want to use Postgres database, you can have an image of Postgres database. Our application here, if you check very well, it's called Swagger 2. The reason it's called Swagger because I was using Swagger. For Swagger is documentation, API documentation. We check on controller here. We have this API operation, whatever this, all these are Swagger endpoints that you show, they give this information when you run it. So when you package it as a Docker image by adding a Docker file, there are many ways of packaging it as a Docker file. You can have a Docker image and quite a number of others. But before, I wanted just to show you how to run. Yeah, it's running, and this I'm using Spring framework here, and it exposes my port as at localhost 8080. So this is my container, my image, my Docker container port. But if you check here, I've said I want it to the container port, which is 8080, but I want it to be exposed at port 9090. So on our browser, we'll come and go to port 9090, localhost, and then we do 9090. Let's see, this everything the app does just displays hello Docker world. Actually, you can get it from here. It's Spring IO. I think this one. Let me check the name. Uh, this is the name. So you can get it from Docker Hub for free and run it. Here it is. If you check it, uh, but before we go on, I want to explain what Docker is. Running, I have my machine here, which is a Linux machine, and most of the cloud, uh, when you are deploying software on the cloud, most of the time you deploy it on a Linux machine. You get some CPUs, you get some, like here on EC2, you get CPU, you get a virtual machine, then you install your Linux system or whatever. If you want Windows, you install. Then you have the management, how you run your application. Let's say on my machine here locally, let me go to here. Let's say you want to deploy a Node application, and the Node version I have here, I think is 10.8, and you want to, if you install, let's say Node, and then V, I have Node 8.10.0, but if you check my application, probably I want one of my instances of application, I want them to run on Node, different versions of Node. So if I run it on this machine, I'll have one choice. That is to run it on Node 8.10, 8.10, whatever. But I want to run different instances of my Node application on different versions of Node. So what I'll do, I'll come and create an application using my favorite IDE or editor. So here I'll specify the image I want. This is from this image. Then I'll add where I want okay, this is what I did with this application. I first built this application and it went to this file. Then I wanted to now to the Docker image to be like this, to be a jar file. In Java, you package your application as jar. Sometime back we used to do .war, but .war or .war, but nowadays we do .jar. So I have my Swagger app.jar. Then this is the port I want to expose. This port is my port. If you check here on my resources, come to application port, application properties, then server.port. This is my application port. This is what I want to expose to the outside. So I have my image now. After I built my application as a Docker image, I can push it to Docker Hub, Why is Docker Hub here? I can push it to Docker Hub, so it will be like, if it's here, it will be Swagger 2, whatever, and then all the other identities. But what I want to explain today, I'll be doing that next time. I'll be creating an application and then packaging it as a Docker image, then get it to Docker Hub. But today I want to show the practical part of it, which is just to get an image from Docker Hub, which is already there, and pull it the same way we do with Git. We'll do Docker pull, then get the image on our local machine, and then we deploy it then we run it on our machine. Then afterwards we deploy it on Kubernetes. For now, let's say I had my application running here. Let's say this application is running on on Java. I'm using Java here. So Java, the latest version is 13, but on my machine for stability issues, I have used Java 11. For, let's say I want to run some of my application running on Java 13. Some I want to run them, let's say they are old school. I want to run them on Java 6 or Java 7 in others. So different, if I install one version of Java on my machine, it won't work for every of these application. So here I have, let's pretend these are different instances of the same, of different applications. So I have my Java, I have my application here running on port 9090. So let's do this. Let me open another terminal and run it on a different port, which is, let's say, port 1991. And let's open another terminal and run another version of this on a different port. Here it is, 1992. So when all the instances run, we'll have 3 applications that we want to expose to outside. This one is starting up, and we have this one starting. This is the one that has already started. So we check on localhost. Let's see, localhost. Localhost 1990 is still running. 1991 is the same instance of the same application. So 1991 is running. It says hello Docker world, and 1992. Let's see. 1992. Yes, it's running on the same thing. Let's check for. We don't have an instance with 1993. So if it runs, we know there's something wrong. So we don't have an instance, so we don't get anything back. We have 3 instances, and if we say all these 3 instances, let's say this one is using Java 7, and the next one here uses Java 8, and the other one, this one uses Java 11 or 13. So if we install all these versions, install one version, it won't cater for all the 3 instances of our application. So we want to isolate our application. We package it with the Java runtime. If it's this application, we package it with everything about this application. We have the configuration, we have the environment, we have the virtual machine that's it will run on, and so this will be a self-contained application. It won't depend on the virtual machine or anything, but to access my machine memory, it will consume my machine's memory, that's RAM, and every cache or anything else. It will also access my disk, which is ROM, to make use of my disk. And every of these instances actually is making use of my system resources. So this isolation is what we are seeking when we are using Docker. Docker helps us do this. And as I said, if you check on a Docker file here, I have my Java here. On my Docker, I said from Java, OpenJDK 8 Actually, this is an image on Docker Hub. Let's go to Docker Hub. Docker Hub, you can come here and just write open JDK, and yeah, I think eight, and you get the image. So I'm saying this is my let me see, open JDK. I'm saying this is my base image for my application. Then this is my base application. So this instance of this application, it will run on Java 8. If I have another application, I can say Java 7, I can say Java 10, or Java, or if it's Node, I can say Node 8, I can say Node 6, anything. Or it's Python, I can specify I want it to run on Python 3 or maybe Python 2. If it's Scala, I can specify actually I want it to run on Scala 2.7 or 2.18 in any. So this, as we are packaging Docker application, we are putting all the resources, everything needed for application all together. We are isolating it from the outside world. So we have several commands. We have this it says from. This means this is the base image. We are running this application against OpenJDK 8. Then we have where to get this is where we get our image from. After I built my application, it went to /target./this, and then we want it to be swagger app.jar. Then the port I exposed it is 7900. You can expose any port you like, Then for me if you're a Java developer, you know very well, if you want to run an application in Java as a jar, you first say Java, then you say -jar, then the application name. So this is, I'm saying, when Docker gets my application, this is how to run it. We actually tell Docker how to do things. So if you are running Python, you specify how to run your Python script here. If it's PHP, you can actually do PHP application and put them on a Docker container. Then this is where you specify how you run your Docker Docker image. So after that, Docker, when you come to your terminal, let's say here, and you run your Docker, this is the commands. But before I talk about the commands, for me to run Docker on my machine on these commands, I first did what we call Docker daemon. I ran Docker a daemon. A daemon is a background process, and I had to run it before. Actually, just write Docker D and then hit, because it's running right now, it can't run again, and it's running on my machine. That's why I can run this. Then after it runs, that's when you come and do Docker, start your Docker run commands or Docker anything. And if you want to see, I have 3 instances of my application. If I want to see my Docker, how many Docker processes I have, I just come here and say sudo is because I want to get the permissions for my machine. But this is the Docker command, Docker PS. It asks me for my password. Docker PS is displayed. So let's look for more commands online. It's taking quite some time. If you come and check Docker commands, yeah, you can see there are quite a number. There's Docker PS, Docker AUX, I think Docker AUX. There is Docker Run for running the, let's see, how many of them? Yes, you can see. You can do Docker Run, Docker PS, Docker Docker PS A. You can do Docker remove if you want to remove an image, if you want to see how many images you have. This one we talk about it. Docker push. This is when you have your Docker image on your machine and you want to push it to Docker Hub. That's why this is quite similar to when you do Git push, when you're pushing your repository to GitHub. So when I'm pushing my code, my application here to Docker Hub, as after I package it as an image, a Docker image, so I'll do Docker push, then it will come to Docker Hub. Then that's where you see when we start doing Kubernetes, you see it being pulled. Kubernetes will pull it from here, then deploy it on the cluster. So for now, these are the commands. PS, let's see if it has worked. PS. Yes, this is when you do Docker PS, it tells you this is the container ID. We had 3 instances of the application I had, and they are running, and it tells you this is a command, the container ID. These are Docker images inside a container. This is the image name, and we have the command. We have how long it was created. The first one we created 18 minutes ago. Then after 10 minutes, we added 2 of them, and then we have, it says it's running on port 9090 on my browser. The one we're exposing is directly connected to the container port, which is 8080. And if you don't give it a name, Docker will give it a name on its own. So these are random names. These are not the names I've given it. So this one of the commands. So let's kill all of them. We do Docker kill. Then we want these IDs. You can line up each of these IDs here. So let's see Docker PS and see how many instances are running. Okay, still running. It says permission denied because I didn't add my sudo. Yeah. For sake of time, let me just kill all of them together. And the second one, and also the third one. What we have seen when running these Docker images is that every time you want to run a new instances, you have to do it manually. So when we start Kubernetes, Kubernetes is the one who will do it for us. It can add more images as we want, and it can also reduce the images. Let's say I had 3 images running here. Docker images here running, but now if you check here we had 3 of them, and here we have 0. So now we don't have, if we come to our endpoints here, we won't have anything running. So localhost 1992, nope, nothing. The site cannot be reached. Localhost 1991, still nothing. Localhost 1990, we have nothing running. Because before I start explaining what Kubernetes is, let me first start Kubernetes cluster here, because it takes quite some time to run on local machine, and I'm using a single node Kubernetes cluster on my machine. But yeah, I'll talk about that. I'm using Minikube. Let me say Minikube start. So it can, okay, sorry. That's not the command. It's Minikube start. After I start Minikube, let me say as it starts, I can tell you if you are not on Linux, you can, there's a very good example. Actually, you when you install Docker on your Windows or Mac machine, you have both Docker and Kubernetes on a machine. You just need to come here and say Docker desktop. Uh, Docker desktop is for Mac and Windows. If you install it, you don't need to install anything else for you to run Kubernetes. To come with Kubernetes, you can see build Kubernetes ready modern application on your desktop. So just one installment. You install once and it runs both Kubernetes and Docker. But for if you are using a Linux machine, just like I am, you need to have, let me see, you need to have a virtual machine, VirtualBox. You need to have VirtualBox. You can see here, my Minikube is running on VirtualBox or VMware. Any of them can do. VMware workstation. You run your. That's why it runs on. For now, I'm going to explain. We have seen if you want 3 instances of our image of our application to run, we need to do it manually. If you check here, let's say VirtualBox. As it starts, let me explain. If you are to run this application, we have to. I have my VirtualBox installed. You can see here, VirtualBox installed. Then I have my Minikube to display. No, it's not displaying, but I have my Minikube installed, and yeah, it takes quite some time. It's preparing that on Docker, and so what's the advantage of using Docker is that you can have efficient use of resources. If we were to use run our application against a virtual machine that uses 1 CPU and 1 gigabytes of memory, most of this it won't be used, or maybe we want to scale and to have an issues. But when we have a container, Docker container running, it will make good use of these resources. So as we wait for Kubernetes to start, let's talk about what exactly is Kubernetes. Is you might have might heard the words Docker. If you listen to words Docker and containers, we talk about containers, we talk about Kubernetes. Actually, if you check on this Kubernetes logo, it looks something like, I don't know if it's let me call it the steering or whatever, the one that steers the ship. So we are using the language that is used on when shipping containers. Let's say we are on a port, like for example, a port like Mombasa, where we are shipping containers to another country, or we are getting the containers coming to our country. So we have the Docker loads the container to the ship, then this being steers the ship to destination. So Kubernetes is what will steer our ship to our destination, which is running our application on the cloud. So we have different cloud application. We have AWS, we have Azure. If you check on AWS, they have even a dedicated Kubernetes clusters. If you want to use their own, it's called EKS. If you check EKS, it's Amazon Managed Kubernetes Service. We talk about what managed means. It's just Kubernetes, but the control plane of the system is not is managed by AWS or Amazon or whatever Amazon. If you come to Azure, we have EKS, which is still managed service, so that the control plane of Kubernetes is managed by Microsoft Azure, the Microsoft company. And so what are these control plane, data plane on all these things? So what if I check here, my Minikube is running. This is my Minikube, and for using, I'm going to start another instance, another terminal, and start dashboard. That the dashboard is, I think, is the easiest way to use Kubernetes. So I'm gonna say Minikube. Minikube just means mini Kubernetes, and let's say I'll just start dashboard. There are many ways to use Kubernetes. You can use Kubernetes using what we call kubectl or kubectl. I have it installed here, kubectl. If I have it stored, this is a client, just like everything you can do on the dashboard, you can use it. This is whatever. CLI means you are running it on the terminal. These are the commands you need. You need to create, whatever, expose, run, if you want to do this. But let's check our dashboard. Our dashboard has a graphic user interface, which makes it quite easy for us to use. And yeah, I think it's running. Let's see on our browser. Yeah, this is it. It's running on. Let me see. Remember, you can comment. You can do anything here. So I had ran different versions of my. This is one image. This is a Docker image. I got it from Docker Hub. And how do you get it? For before, if you wanted to get an image from Docker Hub, what you do, you come to, let's say, let me clear this. You say sudo docker pull, then you get the image name. Let's say we want to pull just let me see, Nginx. I said we use Nginx. Let me come to Nginx. This is Nginx. So the command here is docker pull Nginx. Let me copy this and let's pull it from Docker Hub to our local machine, then run it. Where is this terminal? Yes, sudo docker pull Nginx. So if we pull it, now we have the image on our machine. The next thing, after it has been downloaded to our machine from Docker Hub, we run it the same way we run the other other applications, other Docker images in the same way. Let's say Docker run, but now let's just say Docker run because we don't want to focus much on this, and we want to run our image which we have gotten from Docker Hub. This is let's do Docker run nginx. So it to start nginx, then the image will be running. But since I didn't specify port and everything, I'm not going to. You're going to see it run. I'm just saying this is how we pull from Docker Hub, and then we run the image. So what we do here on our image on it's a bit misbehaving. We have, let me close this because we don't need nginx anymore, and this one. I'll come to this all this. So we have our this is our interface or our dashboard. So here, if you check on my dashboard, it says let me see. It says I have my deployments are running, my pods, my replica sets. Well, but what, if you may ask, what are these pods? What does pod mean? What are replica sets mean? If I can start with a pod is just one a way of the smallest unit of deployment in Kubernetes. It can be one container with its, I'll talk about it, database, let's call them something volume claims and volume claims. It will have one pod. It can have a single, let's say, nginx for just that. It might have attached to 2 or more containers, but the main difference with when you run your image or images inside a Docker pod, when the pod dies, or everything in the pod dies, nothing else. So if the pod is the smallest unit or smallest unit we have in Kubernetes, the replica set is basically what we used to say. Before we had 3 instances of our application, which was Spring Boot application, and we have, if we come back here, we have, it's not yet up. We have one instance of our Docker, our nginx. So if you check here, on this, you can see it has different, let's see, different instances. But let me do just pull from here, something from Docker Hub. I'm going to select an application here. Let me just do the same thing, nginx. We have nginx, so this is what we pull. The simplest way to do it is just come here to create. You on your Docker on your Kubernetes dashboard, you see create a new resource. Then you come here and you say create from form. Then you say the name you want it to have. Let's say just nginx one. Nginx, I think it's something like that. But here you have to specify the name of this specific name here. You have to say it as it is, because that's how Kubernetes will know that we want that specific container image. So we come and say our application is nginx. Then here, this is where we want to run several of them. We want to run several instances of Nginx. So this is what we are going to do. We are going to specify the number of our instances. If we say 2, they will run 2. If we say 3, they will be 3. Unlike we had to do in let me go back to our Docker. If you check here, for Docker, we use, if we had to run on different ports, we had to do this instance, run another instance on port 1991, another one on port 1992. But here we just want 3 instances. They will be running on the same port. So we come here and say we need 3, just as we had. Then here you specify where you do want it to be accessed inside the cluster or outside the cluster. So let's say external, and you specify the port. Let's say what the port, let's say 7900, and the target port, let's say 8080, and then obviously it's TCP. If you use UDP, at least in the container, I don't think it uses UDP anywhere. So then we hit deploy. When you hit deploy, what we have specified here is called the desired state on Kubernetes, that we desire 3 instances of our application, that every time of our application, every time in the lifetime of our application, we want them to be 3. This, why we specify this, probably one application is serving, let's say we have customers like, let's say 10,000, and one application serves 3,500, another instance of the application serves 3,500, and the rest are served by the other one. So we want to have everyone to have a higher availability, that everyone will be using our application. So we want to have a different replication of the same application. So it will take quite some time. I think I need to kill some of my previous instances, my previous applications. So I've talked about Kubernetes, but I've not explained what exactly Kubernetes is. Kubernetes helps us to make it easy to deploy applications on the cloud. Here I have my one, because my machine is just one, I have Minikube, which is just runs on one machine. Minikube. Where is the command? I have Minikube with me, and this is Minikube 1.52 running on my machine, which is Linux Mint 19.2. But on cloud, you don't run it on one machine. Actually, when you subscribe you buy some cloud hosting, let's say from AWS, you want to run your application on different kinds of machine. You want to run it maybe, let's say, for example, let me give you an example that uses the technologies we are talking about. We have Netflix. It's a very good example. Netflix uses AWS for their systems. If we hit netflix.this.com, it's we might think this is one instance of application, but actually there are so many of them that run, and it's running. If we go and maybe I'm watching a movie here in my country, and someone is watching in another country, and we are being served by different instances of application of AWS instances. EC2, this is under compute, and then we come to EC2. Let's say you can see they have listed their customers here. Where are the instances? Let me see overview. Okay, I'm not seeing them. So when running, you won't run your application on just one machine. Maybe probably, let's say, for example, Apple runs their system on hundreds of thousands of we call them, you might call them servers, but most they are referred as nodes in on cloud compute. When you are talking about cloud computing, they are referred as nodes. So let's say, for example, the database that Apple uses for Siri, which is Apache Cassandra, runs like 200,000 nodes on their private cloud. Uh, if let's say Netflix, their movies, they're stored probably on huge number of instances, EC2 instances, which EC2 machines. But so all these machines will be managed by Kubernetes. What you have, we have several instances, several nodes running what we call control plane, and other nodes running what we call data plane. The control plane is basically the thing that controls our whole cluster. So on our control plane, we will have what we call the database. Kubernetes has its own database, which let's say when we said let's say here, for example, actually this is quite good. We desired 3 pods, but so far no pod has come alive, so it's 0. This is the desired state. This is the state it is now. When my previous application, I desired 5 instances of the same application and I have 5 of them. This one, I had 3 and 3, but I scaled down to 0 because I didn't need them. And so I'll have, when running this, my application, probably I might have thousands and thousands of nodes or virtual machines. So my Kubernetes would be running on those machines. Some would be for control plane. We have our database, which is it's easy. Let me see what how it's pronouncing it. That etcd. It's a distributed reliable key value whatever storm, and we'll have all other control stuff there. Kubernetes, you check Kubernetes control plane. You have all, let me see if I can get an image that shows the control plane. Yes, this is our CLI, the one I talked about, kubectl or kubectl. Then we have, when you are talking to Kubernetes, the thing you talk to is our API server. This is what you interact with. When I'm using this dashboard, I'm interacting with the API server. When I'm using kubectl, I'm interacting with the API server. Then we have this, we talk about this. And so this, if you check, this is what we call control plane. When we come to node, we have like this is the master, and we have node 1, node 2, and we can have as many nodes as we want. We have a proxy to proxy. I'll talk about proxy next time, next Friday and the other Friday. We have kube proxy. Actually, you can run here kube proxy. We'll do it later. We run kube proxy here. So this is where our applications will be running. This will be for the control. This is where our applications will be running. If we have this this is my previous application instances. So I had them of I ran them 10 hours ago, and this if I'm not running on Minikube, they'll be running on my data plane, which is these nodes, which will be talking directly to and managed by our control plane here. So that's the basics of Kubernetes and Docker. We checked on AWS and we saw something called EKS and AKS on Azure. Actually, I don't know what AKS means. I know AKS means Kubernetes Service, and Azure Kubernetes Service, AKS. E means Elastic Kubernetes Service. Let's see. EKS. What these services do, instead of you managing your own control plane, they will manage the control plane for you, and then for you, you just need to buy, let's say, EC2 instances. If this is the, let's say you subscribe to Amazon Elastic Kubernetes Service, so you come here, they will run the control plane for you, then you come and buy some instances. Let's say A1 large, A1 dot medium, A1 dot large. The instances, they are named like that. So let's see, where are they? I'm not seeing them. So you buy the nodes, the instances, the node instances from AWS or AWS or Azure or Google Cloud, or what features? IBM Cloud, DigitalOcean. We have Heroku. Anywhere you can buy, you buy those, then you run. You can have a managed Kubernetes service, or you can run your own if you want to control. Most of the time when you want to run your own control plane, is because you want to everything on your cluster to be, you are the one controlling. But if it's just want instances running, you can have it managed for you by Amazon or by Microsoft, by IBM. So those are the basics of Docker. Docker, a recap on what we talked about. We said the first thing, we want to isolate our application, this simple application here. We want to isolate from the system. So we give it a base image and we give it everything it needs. We write it here on a Docker file. Then we build, first you build your application according to what language you're using or what framework you're using. The way you build, if it's Laravel, you build it as it's built. Then you come here and build it again using Docker file. So when it runs, it exposes some port. This is the container. This will be the container port. And then you map it when running. You map it to a port on. It can be exactly the same, or it can be different. Let's say if here I was to, this is the container port, and this it can be 8080. But why I don't use 8080 is because I have my authentication server running on 8080. So if my image is running on 8080 and my authentication server, there will be an issue. So that's why I got for 9090. So it can be anything. It can be 8081, or it can be any port you want. So that's the port you expose. Then you run. If you want if you're using Docker only, you run each of these instances. You manage them manually. If you want to increase, you get another one. You run it. You run an instance of this again. If you want several of them, that's what you do. When you come to Kubernetes, you just declare your desired state. Uh, if you check here, it's saying 80% of the replica sets and pods. It shows you the progress of this. Probably because I'm doing so many stuff at the same time. This one took like 1 minute or so to run the 5 of them, but it's taking some time. Next time I will not do so many stuff so you can see it run. And this is it. When you want to run this application, you first you package after packaging your application, you have coded your application, you package it as a Docker image, you have to have Docker on your machine, and you come on your CLI on your terminal. CLI, and I'm using CLI, terminal, and bash interchangeably. They just mean this thing. So you come here and say Docker push, then you push the name of the image. If it's Spring Boot, you push it. But before that, you need to be logged in. So you need to be logged into Docker Hub. Say Docker, you just say Docker login. This is where is Docker Hub? I closed it. That's all. Let's see Docker Hub. This is Docker Hub. If you check here, it has my name, and this is my own. I've logged in here. So let me log out and we see. If we come here and you want to sign in, you require your Docker ID, which is my name, then my password, then I get in. If I'm not signed up, you sign up for this service, you just come here and sign up for you get your Docker ID, and this is the credentials you use here. If I hit Docker login, first it works. This is for my machine, which I will just write it down. And then it says it's logged in, because it had logged in some time back, just needed this. So if you are logging in for the first time, it requires you to enter both of these, both of your name and your password, so it can pull these images for you. One thing you might be concerned about is if I'm going to push my images here, what about if it's my company's images, like it's the software I'm developing is for my company? This is a public. It's exactly the same as when you do GitHub, public GitHub repos. So if you have GitHub, let me go to GitHub. You have a public repos. So for Docker Hub, these images are public and anyone can access them. If you want a private one, it's unlike GitHub. Let me see. This is my repositories. These are my repositories. This one you can get them purely for, if you pull them from Docker, from GitHub, you get them. But if you check, I have a few of them that are private. Like this one is private, this one is private. For Docker Hub, if you want to get private images, which would be displayed if anyone else apart from you logs in, you have to pay. What about if you don't want to pay? Docker Hub is what we call registry, Docker registry. You can create your own registry. We'll be talking about this in the near future, probably the next two Fridays. So today I wanted just to introduce you to Docker, what Docker is, and to introduce you to Kubernetes. And yeah, Kubernetes, probably these softwares are used by almost everyone in the market. Most application I know of, so many. Google uses Kubernetes for the longest time. Actually, Kubernetes came from Google. They use it for their applications and also for their network. Nowadays, they run some network stuff on Kubernetes, and quite a number of other companies use Kubernetes and also use Docker. So next time I will talk about uh, Docker in relationship to RKT. There is another container service called RKT. This RKT, we'll talk about RKT and Docker. For Kubernetes, we talk about Kubernetes in relation to Apache. Let me see, Apache Mesos. See, not Moses. Mesos. What this means. For example, you'd see some organization using Apache Mesos together with Kubernetes. This is a resource allocation system, and Kubernetes is what we call container orchestration, like it's managing containers. So you can run Kubernetes on top of Mesos. You can run Kubernetes in instances where you would run Mesos, or either way, but this is a resource allocation. This is a resource allocation software, and Kubernetes is a container orchestration software. So if you have questions, you can write them, you can tell them, you can ask me the questions, and yeah, see you next time. And we talk more on Kubernetes and Docker. For Monday, we'll be doing our Monday front-end Monday. On Wednesday, we'll be doing our backend, and next time it will be awesome. And Friday, we'll be doing what we call System Friday. For this, thank you for joining me, and welcome. Okay, yeah. Wow. um, this is, yes. Yeah, make Jan not war. I like this. Thanks. I know Ching Oranga. Ching Oranga is my friend. Yeah. Following Peter Kamau. Thanks so much for joining me. Yeah, make Jar not war. Yeah. Thank you and have a good night. See you next time.